Hello everyone, our names are Emiliano Santana and Angel Mendoza. And our experiment is called on how does the full time of object with different weight vary as the initial height in free fall varies. The objective we have for this experiment is to demonstrate through experimentation on how does the initial height influences the time of an object that is launched from different heights due to the force of gravity, as well as to analyze different final times that we will obtain after launching the object. The materials we are going to be using is a tennis ball, a styrofoam foam, a rubber ball, a plastic ball, a nylon ball, a chronometer, the height of the building, and a phone to record the experimentation. With nothing else to say, let's go to the video.
Analysis of results. In our experiment, we saw clear differences in the fall times of the balls from two heights, 8.55 meters and 4.62 meters. At 8.55 meters, the rubber ball had the fastest average time of 1.50 seconds, while the styrofoam ball had the slowest time at 1.86 seconds. This shows that lighted balls are more affected by air resistance. At 4.62 meters, the pattern stayed the same. The rubber ball again had the best time at 1.22 seconds, and the styrofoam ball had an average of 1.61 seconds. When we compared the two heights, the fall times were more consistent at 4.62 meters. In addition, it's important to note that during the last two attempts with the styrofoam ball, air resistance had a noticeable effect because it was a windy day. This shows how external conditions can change the results, especially for lighter balls. Observations. In this experiment, we analyzed free fall with different types of balls, comparing experimental data to theoretical predictions. The theoretical fall times were calculated using the free fall formula. T equals the square root of 2h divided by g, assuming gravity at 9.81 meters per second squared. From a height of 8.55 meters, the predicted fall time was 1.32 seconds, and from 4.62 meters, it was 0.97 seconds. The experimental results showed that the rubber ball had the lowest average fall time at 0.98 seconds, while the styrofoam ball had the highest at 1.88 seconds. The lightweight styrofoam ball was significantly affected by air resistance, especially during the last two attempts on a windy day. Aerodynamics play a crucial role in the results. Smoother balls, like rubber, encountered less drag, while rubber balls, like tennis, face more air friction, which impact their fall speed. Conditions during the experiment were not ideal. The wind influenced the lighted balls, highlighting the importance of conducting experiments in controlled environments. Repeating the tests was essential for obtaining accurate results, showing how external factors can affect the outcomes. These are our conclusions: theoretical versus real-world data. While theoretical data is useful, real conditions like wind and air resistance can significantly affect our free-fall experiments. Impact of air resistance. Lighter materials, like styrofoam, experience more air resistance, which slows their fall compared to heavier materials. Influence of size and texture. The size and texture of the balls are important for fall times. Smoother surfaces, like rubber balls, face less air resistance than rugged surfaces, like tennis balls. Importance of controlled conditions and repetition. Conducting experiments in a controlled setting and repeating trials helps make our results more reliable and consistent. Comparing heights. Fall times were more consistent at lower heights, likely because lighter balls had less time to be affected by air resistance during their descent. Thank you for watching our presentation. We hope you learned something valuable. If you have any questions, feel free to ask. See you in class.